Good afternoon, guys. So today I am going to discuss and give examples on the derivative and antiderivatives. So first, we need to solve for the derivatives. So in this given equation, we are going to use the product rule in deriving this. So let us recall the equation or the formula of the product rule, wherein it states that uv prime plus v u prime. So we need to substitute the values of u and v prime by these. So we're going to have derivative of v, so we need to get it here, and the terms, normal terms. So u, copy this one, x squared plus 1, derivative of v, 3x squared plus 1 plus v x cubed plus x plus 5, and derivative of u, which is 2x. Now, afterwards, we need to get the answer of this using the FOIL method. So multiply x squared and 3x squared, it will become 3x4. X squared and 1 will become x squared as it is. 1 times 3x squared, that is equals to 3x squared, and 1 times 1 is equals to 1, plus 2x times x cubed, that's 2x raised to the power of 4, 2x and x, that is 2x squared, and 5 times 2x, that is 10x. Now, the next step we need to do is to simplify this term. We need to congest the like terms. So the first like terms, or the first like term that we need to congest is this one and this one. Why? Because it has the same variable and exponent. Alright, so 3x raised to the power of 4 plus 2x raised to the power of 4 is equals to 5 x raised to the power of 4. Alright, next term that we are slightly congesting, the x squared, 3x squared, and the 2x squared. So 1 plus 3, that's 4, plus 2, that's 6. 6x squared. Now, are there any like terms left? No. So we will just bring down 10 down here, and bring down 1 down there, and we got the answer for the equation x squared plus 1 times x cubed plus x plus 5, that is equals to the derivative, or its answer is 5x raised to the power of 4 plus 6x raised to the power of 2 plus 10x plus 1. Alright. Now, that was a ride. We've gone through the derivatives. So now we are going to talk about the antiderivatives. So, we are now in the antiderivatives. So, in this equation, we are going to use the integral form of power rule. So, this is the power rule for the antiderivatives or the integrals. If you are wondering what is n here, so n here is the exponent of every variable of x. So that means 3, 2, and 1 here belongs to n, because this is the exponent of every variable of x. And also, we are going to make our exponent as the denominator and adding it by 1. So we are going to start now. We're going to solve it little by little. So we're starting with the x cubed. Copy x. N is 3 plus 1, that is over 2. 3 plus 1 minus 6 x. 2 is n plus 1 over 2 plus 1. X implies an exponent, which is 1, and that is understandable, plus 1 over 1 plus 1. Now, the trick part is, what is the integration of 1? As the rule says, any constant should be multiplied by x. So that means 1 times x is 1x plus c. We are not in the final stage of our answer yet. We are going to congest each and every exponent we have and each of the denominators we have right here. So x, 3 plus 1 is 4, minus 6, 2 plus 1 is 3, plus x squared over 2 plus 1x plus c. Now, in our answer, maybe we can see some parts wherein we can simplify, or we can simplify it now. So here we cannot simplify it yet, and we cannot simplify it, we cannot simplify that one, this one. Here we can simplify this into 2x cubed, and so copy the remaining untouched equation. X squared plus 2 plus 1x, and that is our answer for the antiderivatives, or the integration or the integral of this given equation.